This screencast will trace the values of the variables in a recursive merge sort. I start with a 5-element array named list. There are 3 method calls inside the method MergeSort. A call to MergeSort that passes the array and then the first half of the list. A call to MergeSort that passes the array and the second half of the list, active at that point, and then a call to merge 2 already ordered parts of a single array together. You can see that the parameters, the integer parameters, first to mid and then mid plus 1 to last, will, as I said, call the left half and the right half of the active part of the array being merge sorted at that time. The base case, the first base case, is to see if first is equal to last. Well, if first is equal to last, then there's only one element. The second base case checks to see if first was plus 1 equals last, which means that there's only 2 elements, because first and last are the integers that MergeSort accepts. The general case, if you don't have one element and you don't have 2 elements, you call yourself, depending on where you are in the recursive algorithm. That's the general case. You can see the index numbers of the contents of the array. Down in the chart, I went ahead and wrote them a bunch of times just to save some writing. But you can see that the first call, we're going to pass the whole array. So when we call MergeSort at the very beginning, we're going to pass it 0 for first and 4 for last. So we ask, does it meet the first base case? No, first does not equal last. 0 does not equal 4. Does it equal the second base case? Does 0 plus 1 equal 4? No, it does not. Then we will put the values of the variables in the table, and we'll proceed with the base case. This is the first time a value for mid has been calculated, and 0 plus 4, first plus last, over 2 is equal to 2. And then in the last column, I want you to write what's going on. And sometimes there's only going to be one thing going on, and something there's going to be 2. I'm going to use the notation MSL and MSR for MergeSort left, MergeSort right, and then I'm just going to use an M to shorten the identifier for merge. And so I call MergeSort left with the list and 0, 2. Okay, so 0, 2 gets put into first and last variables. Does it meet the first base case? Is 0 equal to 2? No, it's not. Is 0 plus 1 equal to 2? No, it's not. Therefore, we call ourselves again. Therefore, we've reached the base case. We calculate a new value for mid. 0 plus 2 over 2 is equal to 1. And we call our MergeSort left again with our current values of, we pass the list, we always pass the list, and first is 0, mid is 1. So this is the first time that we will reach a base case. Have we reached the first base case? Is 0 equal to 1? No, it's not. But 0 plus 1 is equal to 1. Therefore, we've reached the second base case. And so we do what it says. We look in the area of the array that we are in, which is just 0 to 1, and we ask which one's bigger, and we're swapping for this exercise. We're going to swap, we're going to go from order, make it ordered from smallest to largest, indexes 0 to 4. So we swap the -3 and 9 because they're out of order, and then I wrote them on the next row also because we're just going to keep going down on that. But we're not done with what we're going to write in the action column to the right yet, because we determined the bigger one, we swapped, and now we return. And when we return, we're kicking that out of that layer of the recursion. Every time we hit a return, those variables are not going to exist. So I'm going to show in blue every time we return. You don't have to do this, but for me, it's easy to keep track of the value of the variables in that layer of the recursion if I just cross them out. So we've hit the return. What do we do next? We've hit that semicolon for the merge sort left. We're all done with that layer. And so we call merge sort right. We finally made it to the second statement in the recursion. So we call merge sort right. We pass it the list and mid plus 1. So 1 plus 1. Mid is 1 in this layer of the recursion. And last is 2. So we pass it mid. We call merge sort with the integer parameters 2 and 2. Okay, we've hit the first base case this time, and all we do in the first base case is we return. Okay, there's no computation of mid. So when we return, we cross out the most recent 2 values of first and last because those won't exist anymore. We've wound out of that layer of the recursion. And now we're going to call merge for the first time. And merge needs a separate array, which is why I have that table down in the bottom to indicate that when we call merge, we're merging 2 portions of an already sorted array. And so we make a temporary array, and I'm not going to show you all the details, but the active parts of the array are we're merging from 0 to 1, and then unwritten, but then we're going to merge from 1 plus 1, which would be 2, 2 to 2. So those are the 2 parts of the list. We're kind of pretending that they're 2 separate arrays that we're merging. Okay, so those are the only active ones that I kept in red, and so the -3 and the 2 and the 9, they merge together in 1. And then I'll have you show the results of the merged array back in the table. But something that we did do is, even though it doesn't have the word return at the end of the merge, somewhere it's got to be there. We have kicked out of that layer, so I'm going to cross out the second row of column, the second row of the table, the 0 for first, the 2 for last, and the 1 for mid, because those don't exist anymore. And then we're ready to call merge sort right. The value of mid is 2 in that level of the layer of recursion, the one that we haven't crossed out yet. So 2 plus 1 is 3, so we're going to call merge sort right, mid plus 1, 2 plus 3, and the value of last in that layer of recursion is 4, because that's the top row, that's the most recent one that's not canceled out. So we call merge sort with 3 and 4, and we see that we've met the base case. We swap the -4 and 1. We return, so those values don't exist anymore. Then we call merge 0 to 4, the only values left of first, mid, and last. We are sorting the already sorted -3, 2, 9, and the newly sorted -4, 1, putting those all together in one list, and then we're done.